thank you very much for sticking around. My talk is going to be a case study of Brightkite, which is a location-based social network. So just give you an overview of what my talk complements with other people's talk is that, like Chen and Marco talked about, they have continuous data of the user's location. But our case, we do not have continuous user location data. We do have users voluntarily exposed location data, and we know exactly where they are, whether they're at a bar or a restaurant, and we know they are there and when. Okay, so that's the main difference of the data we're studying. But the technique is similar. We use statistical data mining technique, trying to find patterns and interesting things people are doing using this kind of network. So this basically is a motivational slide. We know smartphone market is growing. Although we have 83% of US subscribers still using feature phones, but we expect that number will be dramatically less in the next 5 years. OSN, online social networks, have been exploding since over the past several years. Facebook has more than 600 million users now, and if you combine this to smartphone market and OSN, you'll see a lot of people actually use social websites or social applications on their smartphones. About 91% of users actually use smartphones to use social networking applications. Now, of course, today's theme is about location. Now, if you combine OSN and location service, you get a location-based social network, which is projected to reach about $3.3 billion by 2013. So there's a lot of growth in that market. If you put all three together, it's a location-based online social networks. And this segment has not taken off yet. We see some early startups like the Brightkite, Foursquare, Lowell, and those. So today we're going to just describe our study of the Brightkite. So before we go into it, so what do we define a location-based online social network is that users share their locations, okay, with their friend or with the public. And also there should be an ability to discover other users or content based on location. Okay. There are two types of models. One is the check-in model, that the user explicitly check in, tell the service provider where they are, right? So that is not continuous tracking. The other is the tracking model provided by like Loop or Google Latitude, that clicking runs in the background, always collecting your location information. Now, what we're going to study is Brightkite, which is the check-in model. Okay. Now, this is the web interface and also the smartphone interface of that application. Basically, when you log in, then you can see a list of people checking near you, and also you have the ability to check in where you are. And when you check in, you can say that particular location you want to share it with your everyone, or with friends only, or share with nobody. Right? So there's that's the basic functionality of the website and the application. So the manual data, what we have collected about 2 years of the basically updates from this service, about 4.5 million updates. Checking updates, so basically explicitly tell the service provider the location is about 42% of those updates are checking updates. And when the user check in, they can specify the accuracy of that location. Is that at a particular address, or it's at a particular street block, or whether it's at a particular city. And we see that the majority of the scope of the checking location is at address level. The other popular level is at the city level. Okay. We also collected the friends list, basically the social graph. And also we see about 70,000 users, and we collected their profile information. And about 60% male users, and about 15% are female users. So you can see that this particular service is dominated by the male users. Now, I want to just note that the number of users is actually relatively small. It's only 3,000 users. But remember, this is still early startup. But if you look at the Foursquare, it's actually has taken off significantly. It has reached well over 1 million users since the start of the last year. But nonetheless, by studying this, it can give us a feeling of who are these early adopters and how they are using these kind of services. Now, this is a tag cloud. Basically, every user profile, the user can specify a list of tags or keywords to describe their interest, describe their work, or whatever that they want to put there as sort of a line. And then we basically put extract all those keywords, and then this shows the frequency of those keywords and give us a sense of what are people interested in. And we know the early adopters, they tend to be technology oriented, and so it's not surprising to see like a web technology developer, Apple, Mac, those kind of keywords popping up. But they're also normal users like us. They listen to music, they read books. A lot of photographers, they like to photography, and also many people on the site, marketers that are interested in using social media to do promotion. So that's basically an overall sense of what are the users, who are those users are. Now, then we basically try to classify the users. So we want to group the users. We want to basically study are there sort of main cluster of the users in different behavior groups. So we put together a list of attributes such as the total number of updates during this period, the number of active days. By active days, we mean that that user posts an update on that day. Loyalty is a metric we use to measure how frequently that user comes to the site for the update, and also what's the most recent time. So the higher the value means that the user is more loyal to use this service. Unique places that the user check into, the number of friends. POP is a metric basically we can study the ratio of the user's protected updates divided by the total number of updates, right? So the POP basically is a measure to show how that user is sensitive to expose that application. The higher that ratio is, means that the user protects more of these updates. Okay? And then the first row is basically the average. Okay? The average over all the users. Then we run a clustering algorithm trying to put the user into different groups. So we see that this group that we named the trial users, they basically kind of use that try this service and they never come back. Right? So they try this service and found it's not interesting or whatever, their friends are not on site, so they decide not to use it anymore. And you can see they only like 3 updates use it about 2 days, then they're gone. And that's actually 41%. Temporary users, they do this a little bit more than the trial users. They send about 16 updates, active about 1 week, and visit about 6 places, only get like 2 or 3 friends on the site. And these users, again, they use it for a while, maybe a week, and then they stop using it anymore. About 24% of those users. Normal users, this probably is core active users. So typically, all the metrics are very close to the average. Right? It's about 23% of the users are, we call them normal users, typical users. 72%, 72 updates over the period, active about 1 month, so on and so forth. Now the next group is we call active users. So these are really probably enthusiastic about the service, and we use this a lot more frequently than other users. You can see that they actually total updates is about 650, active about 150 days, and also their loyalty metric is much higher than other group of users. And they visit more places. They visit about 85% of new places, which is much higher than the average. So this, under the average of their friend number is about 34 friends on the site. Privacy group is, is people that are more conscious about their privacy, that they tend to have a higher ratio of their protected updates. So they have a large percent of update they only share with their friends or not exposed at all. So this is about 2%. So basically you can see that it's about 34% of the users are active and more use a lot more. Okay, so next we want to study can we, people are communicating and connecting with each other on this site. So next we want to say, can we sort of understand the connection between the people on this site, and can we predict whether given two users are they likely to become a friend on this site? So intuitively we know that in real life we become friends if we share some common interests, we belong to the same community, our kids go to the same daycare, those kind of things. And also tend to be geographically close, right? If you go to the same, in the same city, then you have more chances to become friends than any two users on the world. So then we basically come up with three metrics, and we basically study the similarity between any two users using these three metrics. Then we combine them and try to predict and try to model whether two users are likely to become a friend. So this is basically, so I'm not going to get into the details, but this basically is a metric using tags. So we can study the similarity or the strength between two tags. The rationale behind this is that if we have two tags shared in our profile, then our similarity is stronger than two users who share only one tag, right? So that's the basic idea. And this is the social distance, basically, is how far away on the social graph, right? So if we are directly friends, then our social distance is only 1. If we share the same a friend, then our social distance is 2. Now the intuition behind this is, if we are close for the social distance, then we are more likely to become friends. And so finally, then we want to do the location distance, basically how similar are we based on the places that we go to, right? So we basically divided this US map into bricks. So first we divide it into 4 regions, and we look into every region. If the total population in that region is greater than threshold, then we continue to divide that region, split into another four regions, and then look into those sub-regions. If the total population in that sub-region is still greater than threshold, then we continue this process until we split the region. Then every region, sub-region, the total population is less than this threshold. Okay. Now we have a list of the region, and we can calculate every user's number of updates in each region, and then we can compare these two sequences of any two users. Then we use the similarity metric to compute the similarity between the two users. Okay, so we basically combine these three metrics, and we're trying to predict whether the users are likely to become friends. And so we use some existing data to do the training to calculate the parameters. Then for the next 45 days, we look at what happened to the network. Are there any new connections are created? And we're trying to predict using our model to see whether we can capture those new friendships created over that 45 days. And we compare our method with naive Bayes and J48 decision tree algorithm, and we can capture 90%, which is better than the other two algorithms. But more importantly, we think is the ability to make top recommendations, right? So if the top predictions. So given if you recommend, okay, so I'll back off a little bit. So the ability we have in mind is make recommendations. So we want to recommend it to a user. So here's a list of users that you might want to check out. They share the similar interests, and you may want to be friendly with them, and you're geographically close. Now, if you make a recommendation, if you give 1,000 users to that user to check out, then likely that user will only check out maybe 50, top 50, or maybe top 20. So we look into the top portion of the recommended list, and we see that our performance is significantly better than the other two approaches. And then next we look at the information gains for each attribute, basically to see the importance of each attribute, to see to predict that friendship. And we see the social distance is not surprisingly is the most important part. Likely that the user find a new friend by looking through their existing friend, right? So they explore the social graph in this way. Now the location metric is also very important. It's just a little bit behind the social distance. Tag metric, because of it, our calculation turns out not very important. Gender difference, not significant, not important to predict this friendship on this particular website. Age difference is not different. Now these two results are different than a study conducted by Microsoft researchers. They basically studied the friendship over the MSN instant messaging network, and then in that case, it turns out the gender difference and age difference matters a lot for the communicating friends. But for this kind of network, turns out they are not important. Okay, finally, I want to just quickly go over some results. We see how users protect their location updates. Okay, so when the user do a check-in, that user has three options to share that check-in with everybody, or with friends only, or with only me. So it's off-the-grid check-in. So there are three options. Now for us, we can only see the updates that exposed to everybody. Right? But on the other hand, we do know how many total updates that user has made, and then we can compare that number with the actual number of updates we have seen. Then we know how many updates that user has protected, right? Has hidden from the public. All right, good. So this is basically the metric we use. Is basically the number of protected updates divided by the total number of updates. If that is very high, which means that user protect a lot of updates. Okay. And also we look at the scopes of that checking. Basically, the scope, the accuracy level that the user has reviewed regarding that checking, whether it's the actual address or whether it's just a city name. All right, so this we look at the gender and the age. The first table basically shows that male users tend to have a lower the POP metric. Basically means that the female users tend to be more privacy conscious. Right? So this is consistent with other findings where the female users tend to be more privacy conscious. Notice that about 27% of users actually didn't specify their gender. Right? But on the other hand, we can see that their POPU value is very close to, it's closer to the female. So this hints that those users who didn't specify their gender are likely to be female users. Now this is the correlation with age. Now we have a large percent of users who didn't specify their age. Okay, they specify either 0 or normally a large number like 99 or 100 years old. And those users tend to be privacy conscious as well. Right? So they didn't even say their age, and then they tend to be, protect their updates more. And the general trend is as your age grows, then you are more likely to be privacy more conscious. So you share less updates with the public. Now this basically correlates with mobility. So the number of the visited location, if you visit more location, then you tend to share less of your updates with general public. Now this graph basically shows now the Y here is the average scope. Basically, The higher value of this scope means you are sharing more accurate of your. I'm sorry. The higher value of Y means that you share less accurately of your checking location. Now, this is basically the more places that you go to, you actually tend to be sharing more accurate values. Now, this seems to contradict with each other, right? Here it says the more places you go to, you share less. Now, here it says the more places you go to, you share more accurate. Okay. So one possible explanation is that the mobile user who go to a lot more places, they tend to be more privacy conscious because they share more places, they check in more. But once they decide to share, they share more accurately. Right? So once they decide to share, they will share more accurately. If they don't share, they don't share at all. So they won't say I'm at Lowell or I'm at UMASS. So it's a different sort of privacy protection behaviors here. Here basically it correlates with friends' numbers. So the more friends you have, actually you tend to share less. You tend to share only with maybe your friends, but not with general public. Now here it basically says my privacy protection behavior, the ratio of my shared updates is actually correlates well with my friend's behavior. So the user have similar, a friend have similar behaviors. They tend to either share more or they tend to either share less, right? So it's a correlate sharing. Here is basically a quick summary, because for every update we know where it comes from, whether it's from iPhone, whether it's from Android phone, whether it's from web, or whether it's from SMS. And we can see that iPhone users actually tend to share less. Right? They protect more of their updates. On the other hand, the web you tend to share them. Regions, Asian users, to my surprise, is actually tend to share less. The ratio is that of the protect updates actually is higher than the west of US, central US, east of US, Europe, all in this group that they tend to be more privacy conscious than Canada, Africa, Russia, and South America. Okay, I think I'm going to skip these 2 slides. Alright, so more information, go to my website. We have several papers published, and also my student who did this work just successfully defended last week, and he's looking for a job now. So finishes, let me know. Okay. Any questions?
You can save the questions perhaps for after the meeting, because we are like 45 minutes behind.
Okay, all right.
Thank you so much.
Sure.